Hi, this is Luke Johnson again with Hach Company, and in this video I'm going to show you how to run our ultra-low range total iron procedure with our DR3900 lab spectrophotometer. So first of all, I'm in a hood, which is important because we're using ferrozene reagent for this chemistry, and ferrozene reagent is toxic and it smells unpleasant. So we're going to make sure we run this in a hood. Here are the 5 vials that we took from the previous video, from the calibration video, and first one here I've dedicated as the blank, recall, and then these 4 were the samples. You can see on these vials that I have marked a fill line here. I did this by adding by pipette 15 milliliters of water, and then I marked a line at the bottom of the meniscus, and that's the fill line that I'm going to use for this analysis every time I run it. Also important to note, we took the sample from the turbidimeter in these vials, and that's important for 2 reasons. First of all, sample containers can be contaminated with trace iron, and we want to avoid that because these vials are clean. We don't have to worry about that contamination, but we also don't want to lose particulate or colloidal iron to the sample bottle, as iron can adhere to the plastic or the glass, and then by the time you try and transfer that sample into the digestion vial, you may have lost some of the iron, so your results are not representative. So before we run these for the first time, we want to make sure that they're clean, because these vials can have trace amounts of iron in them as well. So when I get a new vial, I will mark it. I will add 15 mils of deionized water, and then I will add the ferrozene reagent just like I would to a sample blank. I've decanted some of the ferrozene reagent into this dropper bottle, and that helps me to avoid contamination as well, because frequently the tops of these bottles can develop a crust, and if you get that into your sample, you will have a not representative result as well. So like I said, I decanted some into this bottle, and I'm going to add 10 drops from this bottle into each sample vial. If you overshoot it by 1 or you undershoot it by 1, that's okay. I've tested this with 9 and 10 and 8 and 12 drops, and the results are the same, so you don't need to throw away your sample if you happen to overshoot it. So after I've added the ferrozene reagent, I'll invert this a couple times and place it in my DRB 200 reactor here at 150 degrees. Now, like I was saying, for the first time we do this, we want to digest we want to clean this vial to remove all the iron, and we do that by digesting with the ferrozene reagent for at least 24 hours straight. In order to do that, we set the block at 150 degrees Celsius, and we don't hit the start button. The block will stay at that temperature until you turn it off, or you hit start, and it will run through the timer cycle and then shut off the heater. So whenever I get a new vial, I'm going to follow this procedure, drop it into the DRB 200 and let it cook for 24 hours at least. So after that period, remove the vial, let it cool down. Obviously this one's not 150 degrees. You don't want to burn your hand when you take it out of here, so be careful. Let it cool on the bench for a while. Once it's safe to handle, dump out that cleaning solution, rinse the vial, and you're good to go. You have a clean vial for future use. These vials, if you recall, were all from the turbidimeter, and we sampled them all together, and I'm going to prep them the exact same way that I just prepped this one that we were using as the example for cleaning. I'll add 10 drops of ferrozene to each vial. Cap each vial. Invert them a couple times to mix, and then drop them in the DRB 200 reactor and digest at 150 degrees C for 30 minutes. once the digestion is complete, we're going to let these vials cool down to the point where they can be handled safely. You can let them cool on the bench top. You can cool them in a water bath. The glass won't break under either condition. And then we're going to come here to our spectrophotometer, load up the procedure for this method. There's a pour-through method on the DR3900. If you're using a DR6000 or a DR5000 with a larger cell compartment, you can run this method with a 10 centimeter cell. I'm not showing that in this video. So this is the pour-through apparatus. We have the sample funnel here and the sample cell here. We want to make sure that we put this, that we install this correctly. That's essential to getting good results. So take the cell, align it such that the 1 inch path length runs front to back for the instrument. You don't want to do it sideways. This is a 1 centimeter path length, and that would be incorrect for this application. So make sure that this is seated fully into the cell compartment. Excuse me. Here I have the sample funnel, the inlet tubing. I've also clipped as short as possible. The pour-through cell was designed to be run with a 25 milliliter sample volume. But these vials only hold 15 mils, so in order to make sure that these can work together and that the sample cell is flushed thoroughly, I've clipped the sample line as short as possible. We also want to make sure that we don't have any bubbles in the sample window here. The bubbles will cause an erroneous result, so we can eliminate bubbles by just gently tapping the cell. Maybe fill the funnel with some water and rinse it through while you're tapping. If you're having a lot of issues with that, you can also rinse the cell with isopropanol. Just fill the funnel here, and isopropanol will also remove the bubbles. You want to make sure that you rinse all the isopropanol out of the funnel before you run your samples. So I'm just going to rinse this a couple times. I'm collecting all of the sample waste back here in this beaker, and I'm going to transfer that into this jug that I've labeled ferrazine waste. Again, that's because ferrazine is toxic and it smells terrible. The pH on this waste will be about a pH of 4, and all that's in here is the ferrazine reagent and your sample. So now that I've got this rinsed out, I will add my blank. Just pour it straight in. I'm going to rinse this vial into my waste container just to get the residual smell out before I remove it from the hood. So after I've let the sample settle, I will hit 0 on this one because this was my blank. And then I will rinse the funnel again. And then we'll transfer my first sample. Same thing, just pour the entire sample into the funnel. Allow the sample to settle. And then hit read. It says we had 0.5 parts per billion of iron in this sample. I'm gonna rinse out the sample funnel again. When I'm finished with my analysis, I want to make sure that my funnel doesn't get contaminated with stray iron, so it's a good idea to put some like parafilm or a cap or something over the top of this, and also to dedicate this sample cell to this analysis. Don't use it for ultra low range silica or other procedures that might use this cell. You want this one to be dedicated to iron. In order to maintain the cleanliness of our vials, after every analysis, it's a good idea to fill this vial again to the mark with 15 mils of deionized water and add some more ferrazine. This just makes the inside of the vial a a nice clean environment. Any iron that might be residual in here or that might come into contact with the vial will be complexed with the ferrozine, and then I could just dispose of this before the next time I'm going to use this vial. That was the ultra low range total iron application in a nutshell. Please feel free to visit our website, hach.com/power, to find this method and other application notes that can give you more information.